Hi, I'm Krista, and Greg's here in the background. You'll see him in a few minutes. We did our project today on a chapter in our math book that is finding area with polygons. And so we were able to outline our project, and we figure that it's going to take about 22 days, 23 days to complete. And we were able to not only apply our Common Core standards for finding area, but then we were able to use Scratch to build upon understanding and to really get the kids to be able to create their own images and show why formulas work. We have an hour and 20 minutes a day that we're able to devote to our math lessons, and so we easily reach that 25-hour mark. On the first day, we review parallelograms. We talk about why the formula works. We derive it from a rectangle, and then we're able to apply that formula of base times height and have the students find area.
Once we introduce the lesson with the students, we then go right into our very first Scratch lesson. However, before we can start drawing the actual parallelograms, we need to introduce the pen feature, which is an extension. So as you go down through the lesson plan, you will see how we tell the students to log in, go identify the pen extension where they're going to have to find it, select it so it appears down their left toolbar. Once you look down here, you will see then we'll just do some mini introductions on pen, using the pen, such as just drawing a line. In this case, we drew the line, change colors once you get so far, and then also increasing the width of the size of the line. I will include some sample coding for teachers, maybe first-time users, so they have an idea of how to get the pen to work. But once we get through the idea of how to use the pen, we will then go ahead and go to the next page, which would be day 3, and we'll actually take that pen feature, go ahead and draw some sample parallelograms. So once again, a basic overview. If we go down here, I have some code that shows you primarily a big thing we need to focus on with beginning Scratch teachers is how we need to activate the green flag with the erase all every time we start over. And if you scroll down, there's the starting sample of what our parallelogram would be, and this would be, try to make it fun with the kids, we use the name parallelogram penguin. So it forces them to go in, choose a sprite, and then that sprite designates, hey, when I see parallelogram penguin, tongue twister as it is, that will be the character that shows our parallelograms.
On day 4 then, we're ready to move on to triangles. And so we review a little bit about what it is to be a triangle and their qualities. We're able to identify base and height, and we're also deriving the formula from a parallelogram so that they can understand why it works.
So triangles, as Krista mentioned, having to understand base and height depending on which rotation the triangle has can be a little bit tricky. So we kind of broke the triangle Scratch project into 2 days. The first day pretty much focusing just on 3 sides, 3 angles that add up to 180 degrees. So if we go down to the sample, provided code here for you, but now we have the toucan triangle, and all you're going to want to do on day 1 is just introduce turning the toucan so that students can learn the 180 degrees interior and making sure that it's an enclosed figure. However, once we get into the second day of Scratch and triangle composition, this is going to be where we're going to break it down, and we're going to see push some kids that really need the challenge and they can accept the challenge. We're going to push them to the limit, really get their mind kind of into the computational thinking aspect. Is we're going to have 6 options, and obviously every kid's not going to reach the same, but it's going to provide a challenging aspect nonetheless. We're going to have kids possibly work on scalene, isosceles, or right triangles, so we're forcing the line segments to be different sizes to meet those requirements. And then an option, if they finish all that, we can go on to making triangles that focus strictly on their angles and the different type of angles, whether it's an obtuse, acute, or right triangle. So if we would scroll down, for example, here's toucan triangle, And here we have a right triangle with the 90 degrees. Here we have an obtuse triangle. And when I had my toucan drawing them, after it would finish drawing one, you could have the students, for example, have the speech quote, little bubble, and the toucan triangle said, right triangle. The toucan would then jump up here, draw this figure, bounce over here and say, obtuse triangle. So you could add more components in as you go to let the kids go, and you can see, I think I have that listed there, that's a possible challenge little extension that we can push our higher level learners.
As we get to day 7, we begin to introduce trapezoids, and that formula is always a little bit trickier because they have to identify not only one base but two and understand that it is the parallel sides. And so we're going to focus on identifying the right angle, figuring out those parallel sides so that we can plug in the right information to the formula. And we also derive the formula from a parallelogram so that they can see why it works.
So now we're into trapezoids with Scratch, and we're going to use trapezoid Terra as our new sprite character. So students can associate sprites with certain figures. If we scroll down to trapezoid Terra, here she is walking her way around a trapezoid. This is just a very basic feature just to get them to draw. Now we could get advanced and we could actually reposition. You could work on positioning Terra so she is standing upright if you want. But once again, that's a little bit higher level. But for right now, we just need to work on getting, as Krista said, we need the parallels, we need to show a 90, and we could always go in there later and create some type of paint and a broadcast feature, which I will show as we further down into our progression here.
Our next lesson has to do with finding area of composite figures, and they're able to then see that if, I break it into different parts, I can use the formulas for trapezoid or parallelogram or rectangle and be able to then add together the areas of each of the pieces to find the area of the composite. We'll also then talk about breaking it apart by adding on. And if we add on to the larger picture, then we can subtract off the piece that's added on, possibly a triangle, something like that, and then find area by subtraction.
So we head into the Scratch lesson, and it's a little bit different theme here. We're not going to have a character necessarily walk around and draw it. What we could do is we can have the students go into the paint their own sprite, create their own sprite. And if we go down here and look at my figure, just something simple in having, I drew a rectangle, added on another rectangle, erased off the black line with the same color paint as you're using. So basically a letter L, you could say, to start off, and you can see my hand-drawn paint units that are giving specific lengths and widths on this composite figure. You could then have multiple ways. I mentioned that we could take our sprite character, you could put a little eraser in their hand or a paintbrush. You could have the sprite character walk across and either cut the two rectangles horizontally, or if you want to, see if it challenges students, they could do it horizontally and vertically. But they could introduce taking their sprite character and showing that they understand how to break up the composite figure. Go down to the next one, coordinate geometry. This is you, Krista.
This last lesson has to do with being able to plot ordered pairs and connect them, determine what polygon it is that they've created, and then be able to use what they know about base and height to find the right angles, to find area, and also to be able to find perimeter of some of the objects as they're drawn on the coordinate.
So coordinate geometry, fortunately for us, Scrat has the wallpaper, or the background choice of the X and Y. We are going to introduce the broadcast feature here, which is a very nice feature for calculating distances, height, lengths, widths. But if we'd scroll down, ignore the missing lines in my coordinate background, but needless to say, you start off with having your sprite character draw the shape. In this case, we have a rectangle. You do not, the ordered pairs will not be displayed at first. You'll have your sprite character walk around, draw the figure. Once the sprite character came back and connected to make it an enclosed figure, I then have my sprite character jump inside the figure, and this is where you broadcast. When you finished on this last segment, broadcast done, show ordered pairs. And as the sprite character would jump inside the figure, these ordered pairs then pop up. So once the ordered pairs are up, that is what the students then use to calculate, obviously, a unit of 5 units, distance of 6 units, 5 units, and 6 units using those ordered pairs. So you can slowly get into higher levels along Scratch, and in this case, broadcast feature would work wonders for that.
We wrap up the textbook with a review for the chapter and the chapter test, and there's an online review that the students can complete, and based upon their results on that review and feedback that we received from them, we would do more examples with the students so that they felt prepared for the assessment.
So our culminating activity that would incorporate Sprite with all the targets that we featured in the chapter 4, we're going to ask students to think about a career, and in this case we'll just talk about being possible an architect, and say we're an architect and we're going to design a playground. Obviously keeping it something in the minds of 11 or 12-year-olds, something that they're familiar with. So you could have the students go ahead in and they'll be using coordinate geometry to lay out a playground architecturally, and within that playground we would ask them to create areas for a swing set. We would ask them for an area of a sandbox, and another area of a life-size chess table, and then whatever is not occupied with the swing set, the chess table, and the playground equipment, we're going to have the students bring in mulch, and they'll have to figure out what remaining or leftover part of the playground needs mulched out. We could also incorporate money with that, a price associated with each yard of mulch. But it's an excellent way that you can have students lay out architecturally. They would design a playground, different parts, different regions within, and then they can calculate a bunch of different topics that we just talked about throughout the chapter. Rubric for Krista.
We found a rubric online that we thought really worked well for us, and we were able to adapt it to better meet the criteria that we were looking for. But we started first with 3 areas of math that we wanted to see the students making certain that they were using, both from this chapter and possibly from before, that they might need to know. Next was the thinking area. And again, 3 areas that we were looking at: their reasoning, process and inquiry, creativity, and reflection and evaluation. Not just going through the steps, but actually kind of owning this project. Personal development, meaning that not only are they showing growth on their part, but they were taking control and staying on track, using their time wisely, asking for help when they needed it, and forging ahead to complete the task. And we included then information technology. Both they were creative and showing that they can think visually using Scratch. And that wraps up our lesson.